On October 5, 2024, Russia's most advanced fighter jet shot down Russia's most advanced drone on purpose. An Su-57, Russia's only fifth-generation stealth fighter, fired an air-to-air missile at the S-70 Okhotnik, Russia's most ambitious combat drone ever built. This wasn't some disposable reconnaissance UAV. The Okhotnik, Russian for hunter, is supposed to be the future of Russian air power, a stealth combat drone that could fly alongside the Su-57 to extend its reach deep into enemy territory. Russia's own documents called it a sixth-generation unmanned aerial vehicle. Over a decade of development, a program so secretive that the first prototype wasn't even seen publicly until 2017, and in a single moment, it was a pile of wreckage in a Ukrainian field. But to understand why that matters, you need to understand what this drone actually is. The S-70 Okhotnik is not a small drone. This thing is massive. We're talking about a flying wing with a wingspan of around 20 meters. That's roughly 65 feet, comparable to a manned fighter jet. It weighs approximately 20 tons. To put that in perspective, most combat drones in service today weigh a fraction of that. A Turkish Bayraktar TB2, for example, weighs well under a ton. The Okhotnik is in a completely different class. It's built around a flying wing design with no tail and no protruding fuselage, shaped specifically to minimize its radar signature. The airframe uses composite materials and stealth coatings to reduce visibility even further. It's powered by a variant of the AL-41F turbofan engine, the same family of engines that powers the Su-57 itself, giving it a reported top speed of around 1,000 kilometers per hour. Its range is claimed at 6,000 kilometers total, with a combat radius of about 3,000 kilometers. If those numbers are real, this drone could strike targets deep behind enemy lines and return home without refueling. And it doesn't carry its weapons on external pylons where radar can see them. The Okhotnik has two internal weapons bays designed to hold up to 2,000 kilograms of guided and unguided munitions, all tucked inside the airframe to preserve its stealth profile. The Okhotnik's roots go back to at least 2011, when the Russian Defense Ministry selected Sukhoi to lead a program for a new heavy unmanned reconnaissance and strike aircraft. But Sukhoi wasn't working alone. They were joined by MiG, Russia's other legendary fighter design bureau, and the new drone drew heavily on data from MiG's earlier SCAT program, a UCAV concept that never made it past the mock-up stage. The actual construction work was handed to the Novosibirsk Aircraft Production Association, a manufacturing plant within the Sukhoi company. For years, almost nothing was known publicly. A ground test mock-up was built in 2014. Then, in July 2017, a prototype was revealed for the first time, and the world got its first look at that distinctive flying wing shape. Things started accelerating in late 2018. In November, the drone performed its first taxi tests on a runway at the Novosibirsk plant, fully autonomous, reaching speeds of 200 kilometers per hour. By January 2019, the first flyable prototype was spotted being towed around the facility. And around the same time, something interesting showed up on a Su-57. The third flyable Su-57 prototype appeared in a new digital camouflage scheme with the silhouette of the Okhotnik painted on its fuselage and a lightning bolt symbol between the shapes of the two aircraft, a clear signal that manned-unmanned teaming was the plan. By May 2019, the drone was making short hops, flying just a few meters above the runway. And then, on August 3, 2019, the Okhotnik made its maiden flight. It stayed airborne for about 20 minutes and circled an airfield at Akhtubinsk at an altitude of 600 meters. Not exactly pushing the envelope, but a genuine milestone. Less than 2 months later, the Russian Ministry of Defense released footage of the Okhotnik flying alongside a Su-57 for the first time. The drone reportedly flew autonomously for over 30 minutes to test its ability to extend the fighter's radar coverage and target designation range. The concept was simple but powerful. The drone goes where it's too dangerous to send a pilot. In February 2021, reports emerged that 3 more prototypes were under construction, with improvements to the avionics and airframe. The third and fourth prototypes were supposed to match the planned production version. Later that year, a second prototype appeared with a significant visible change: a new flat exhaust nozzle replacing the original round one. That circular nozzle on the first prototype had been a glaring weakness. It was essentially the same kind of exhaust you'd find on a conventional fighter that did nothing to hide the drone's heat signature or radar reflection from behind. Weapons testing followed. Unguided free-fall bombs in 2021. Precision-guided munitions in 2022. By August 2023, Russian officials were saying state tests would wrap up by the end of that year, with mass production starting in 2024. The vice-governor of Novosibirsk confirmed in January 2024 that serial production was expected to begin in the second half of the year. On paper, everything was on track. The Okhotnik was about to graduate from prototype to production aircraft. And then came October. But before we get to what happened, it's worth understanding why Russia was building this drone in the first place. Because the Okhotnik wasn't designed to operate alone. The idea is something called a loyal wingman. Instead of sending a pilot into the most dangerous airspace, you send the drone. It flies alongside a manned fighter, in this case the Su-57, and acts as an extension of the pilot's eyes and weapons. The drone pushes forward into contested airspace, using its sensors to find targets and relay that data back to the fighter. The pilot stays at a safe distance, makes the decisions, and can launch weapons from well outside the range of enemy air defenses. If the drone gets shot down, you lose hardware, you don't lose a pilot. It's a compelling concept. And Russia is far from the only country pursuing it. Every significant military power has a similar program. This isn't a niche experiment. This is where military aviation is heading globally. And that's what makes the Okhotnik story so significant. Russia is trying to build the centerpiece of their next-generation air combat architecture. The Su-57 was always a relatively small production run. Russia can't afford to build hundreds of them. But if each Su-57 could control one or two Okhotniks, suddenly that small fleet becomes far more capable and far more survivable. In October 2024, an S-70 Okhotnik and a Su-57 took off together from Akhtubinsk Air Base, a major flight test center deep inside Russia, roughly 600 kilometers behind the front lines in Ukraine. This was an operational test flight. The drone was airborne, armed, and flying in a real-world environment relatively close to an active war zone. And then, something went wrong. The Okhotnik lost contact with its ground control station. The drone kept flying, but nobody could tell it what to do, and the direction it was heading was the worst possible one, straight toward Ukrainian-controlled territory. For a normal drone, this would be bad. For the Okhotnik, it was a nightmare scenario. This was one of only 2 prototypes ever built. It was loaded with some of Russia's most sensitive stealth technology, composite materials, radar-absorbing coatings, classified avionics. And it was armed. Wreckage later confirmed it was carrying a UMPBD-30SN glide bomb, a relatively new precision munition. All of that was now drifting toward enemy hands. The Russians tried to regain control. They failed. And by the time they gave up, the drone had already crossed the front line into Ukraine. So the Su-57 did the only thing it could. It fired an air-to-air missile and brought the Okhotnik down near the town of Kostiantynivka in the Donetsk region. Russia's most advanced fighter had just killed Russia's most advanced drone. But the story doesn't end there. The crash site was out in the open in Ukrainian-held territory. Large pieces of the Okhotnik survived the impact, including a big, relatively intact section of the wing. There were stealth coatings to sample, engine components to examine, and avionics to reverse engineer. The the CIA was about to have a field day. Russia knew this, and their response was blunt. They reportedly launched an Iskander ballistic missile at the crash site to destroy whatever was left before anyone could get to it. But they were too late. By the time the Iskander hit, Ukrainian police had already arrived at the crash site, documented the wreckage, and hauled away the most valuable pieces. Footage confirmed large, relatively intact components being loaded up and removed. So, in the span of a few hours, Russia lost a prototype worth an estimated tens of millions of dollars, revealed that the drone was being tested with live weapons near the front, handed wreckage containing classified technology to the enemy, and then failed to destroy the evidence. Now, it's easy to look at this and call the whole program a failure, but that's not quite right. The fact that Russia was conducting armed test flights near an active combat zone tells you something. They had gotten far enough in development to trust this drone with live munitions in a real operational setting. That's not nothing. The program had been making steady progress for years with new prototypes, improved stealth features, and successful weapons tests. But the October incident exposed a fundamental problem. If you're building a loyal wingman, a drone that's supposed to fly into the most dangerous airspace imaginable, it absolutely cannot lose contact and go wandering off on its own. Reliability isn't a nice to have, it's the entire point. And now Russia faces an additional problem. Whatever technology the Okhotnik carried is likely sitting in a lab somewhere being picked apart. It is flowing to every Western ally with an interest in understanding Russian capabilities. Russia says serial production of the Okhotnik is moving forward. Maybe it is. But between the loss of a prototype, the compromised technology, and the very public embarrassment, the program is in a very different place than it was a year ago. Whether the Hunter ever becomes the weapon Russia needs it to be, that's still an open question.